So, are you guys here to talk about Flash and databases?
Yeah.
Yes. Yeah.
Wow. I forgot about it. I was like saying to people and signing up, you know what, people are. Okay, guys. So I didn't plan to use project or anything. Mainly wanted to chat to you and see what your experience is. Maybe to share experience what you guys have.
Let me start?
Yes, let's.
Sure. I don't have a lot of experience in Flash. I played with it a little bit. I just bought a couple of the Intel, ones off the shelf and plugged them into a regular SATA enclosure. It was really fast, but it's still cost prohibitive at my last place. But I'm going to Facebook in a few weeks.
And you're going to learn a lot about Flash, right?
Right. So I'm hoping to learn from you guys,
Okay.
and know what I need to know for that.
You're going into operations?
Yeah. So that's it. That's mine.
Okay, sure. I'll probably go last for what's about you.
Basically, we just use Spindles right now.
Okay, and you are with.
I'm with DemonWare.
Okay.
Actually, went to the VOF at Velocity.
Yes, yeah. I think I remember you taking notes of this.
Yeah, that's what I did. But basically, we haven't had need for that yet. But it's certainly an interesting topic, and since I'm just generally an ops guy, I'm probably going to be asked to do it, especially since now I'm moving here to probably going to work at Intel anyway.
Oh, so you Intel, huh?
I've never bought a flash drive or used it, but I think there are a lot of interesting questions about how to use it best. File systems are all designed for funny things about disk, and none of those are going to be true, and that's an interesting problem. And you've got a cost advantage and a power advantage for flash, and for a database to find the right way to use RAM and flash and disk in this sort of three-tier hierarchy is also an interesting question.
Cool. I'd like to think I understand how Flash works or whatever, but essentially I have zero operational experience. So probably not doing like yourself. I'd just be interested to hear what people are currently using, what extra problems and things like that it introduces for consideration.
I'm Kevin Lewandowski with Discogs. It's a high traffic music site, and we use Solar for search, and we have 4 boxes doing that, and we just recently put a flash drive in one of those, and I don't have any numbers, but the performance is way better. We just did this a few days ago, so I'm curious what else we can do with flash, specifically on MySQL.
So Solar builds an index, right? And you just put that index onto the flash drive?
Yeah.
Yeah, well, that should be quite good with a Solar. If it doesn't fit in memory well, it does pretty much a lot of smaller random I/O.
Yeah.
Okay, so let me then kind of maybe describe some background on the flashes. Right. So first of all, there are 2 big different types of flash, which you can see. One is like NAND flash, and then NOR flash. Pretty much anything what we see is like on the hard drives, Fusion I/O, that's an NAND flash, which is optimized for like block level access. And in this regard, it's have typically latency maybe about 50 microseconds, right, for access. Another type of flash, which is kind of what Dividend uses, which is kind of relatively interesting in the fact that in the sense that it has very large asymmetry between write performance and read performance. So the NOR flash it doesn't have to be accessed on the block level. It can be pretty much accessed by on a cache line level, and can be seen something like it can hook up pretty much instead of your DRAM for each, right? Just a bit slower, but a lot slower with writes, right? So from what I know right now from in the market, the dividend with like MySQL appliance are pretty much the only ones who use that one. But I think that's very interesting as kind of its parallel technology from what we actually know about Flash. And that Flash is also, I mean, it's not like some absolutely weird thing which nobody else uses. It's used a lot in cases like cell phones and stuff like that when you actually can want to execute the programs from a Flash, right? Not from DRAM, but it is it's not very commonly used for storage, and it's and besides those very kind of relatively slow writes, it's also significantly more expensive, right? So its cost is a bit closer. Now, the second thing you need to know about the flash is what there are two different types of flash, of NAND flash, like SLC and MLC. That's like single layer and multi-layer, right? You're a big flash expert right here.
Other people in the company are.
Okay, sure. But anyway, so the difference here is that SLCs are the performance difference between them for the reads is not very significant. SLC is a bit faster, a bit more faster for writes, but what is than MLC. But what is the main difference here is what MLC has significantly smaller amount of cycles, read-write cycles, what each block can do. I think it's like often about like 10,000 for MLC, and it could be 100,000 for SLC or something like that. MLC is also cheaper and has larger density. So, for example, if you look at the Intel hard drives, they have disks up to 64 gigs with SLC, which is probably very expensive, and MLCs can be 160 gigs or more. Now, another interesting thing to understand about Flash, right? We got used to disks. So what we know about the disks? Well, we have blocks which you can read blocks and write blocks. Well, Flash do not really work that way anymore. You can read the blocks, but when you come down to writing the data, you cannot just like go and overwrite the block. You actually have to erase the block, which applies to two things. Erase is a relatively slow operation, and it has to happen on the like erase block boundary, which is much larger. So it could be 128K, it could be 256K, but basically it is, it's not the same, or let's say sector size as if you're emulating hard drives, or even operation system page size like 4K. It's significantly larger. So that comes to the fact that there is a lot of optimization being done by vendors like Intel and so on and so forth to try to make solid state drives to look similar to hard drives. So what they have to do with that? Well, they typically have to, as you use it over time significantly, they have to do something like clean up operation in the background. When they see, okay, well, when you write the data, it's always written in the new kind of new block, like block structured format. And then you see the holes of a data, which is the old version which nobody else uses. And there is some cleanup thread, like something like a vacuum or whatever, which goes through and it copies this data to a new location so the complete blocks can be erased. And then the system has to erase enough of those complete blocks in the background so it can accommodate the writes. And that comes to a very interesting property of drives, right? We got used to our, let's say, if you take a look at hard drive, plug it in, run read writes for it for a month. We expect read writes, performance to be the same, while it's not going to be the same for solid state drive, because over time you get this kind of fragmentation, which is can degrade performance a bit. You on the top of that stuff, what's I mentioned to you, what it has to override this stuff is also something called write level, where level and something like that, right? Basically, you want to ensure what all your blocks are written about the same time, right? So imagine something now. If I put my data which I never touch, never going to write, right? Some constant data, and it lives on a page which was written only once, while every single page is now having a lot of writes go on them. So even if this is complete erase block which is filled, not modified, the write level system has to really copy that stuff to a different place, which has, for example, which is close to 90% of its write allowance, right? Because now it's better to write put the actively written data to those blocks which are not haven't been written a lot, right?
So does that mean that you'd want to make sure you don't get anywhere near your capacity, so you have a lot of extra space?
Well, good question, right? Really, if you look at the all the new hard drives, what come out there, they over provision.
Okay.
So if you buy, they don't really tell you how much you over provision. What's that? But if it's like 64 hard drive, I don't know, like maybe it's 72 or I don't know what it is exactly, but there is some sort of space which is exactly used for that. Compact for that write leveling. But now more than that, a lot of those drives they really perform better while you only use small space of them because they can see how much of data you have really written and how much was never touched. Right? For example, if you would fill out the drive from a start to there's like 32 megs and you have 64 megs of the drive, well, it will use that remaining space for optimization still, right? And also that small extent that it has. The interesting thing about that is currently you don't really know from operation system level what kind of pages are used and which are not. So as soon as you have written certain pages on the block level, it is for flash level it's used forever. It has to take care about this data which is there all the time. Even though you may have reformatted file system since that time and everything is now clean. There is an API which is being developed like as an extension of serial ATA, whatever interface is, and file system support has been added to that. So you can actually say, you know what, I don't need this piece. So this piece, right, you can kind of free it back and use it for wherever it is, right, and then I read it back, you can just return random corrupt or zero it out.
Is that file system specific or?
Well, I think this is in development.
Oh, I see.
Right. So, and I think actually you're like your Facebook guys didn't they think about implementing something?
They haven't told me anything yet. So.
Okay.
They're just merging it into Linux now. Discard support.
Okay.
Yes. But my point there is another kind of fun stuff which will take a while to get to mainstream. So the interesting trend here, what happens is what like Flash is different from your hard drives, right? But because databases, operation systems, file system, everything is so much optimized for disks, the hardware vendors trying hard to make Flash to have as close properties to the.
I think that's starting to change. Like our product, we use the CFI interface to Flash instead of pretending that it's a hard disk.
Which one?
The Common Flash Memory Interface Protocol, which doesn't make a flash memory look like a hard disk. Instead, it's a standard API to all of this underlying reality.
Okay.
I'm really looking forward to when someone writes a storage engine or a database that speaks to CFI instead of pretending that it's a hard disk.
Yes, well, and I can tell you, I think in a lot of cases, what I see people trying to optimize some of that stuff, but I mean, there is so much legacy. If you look at the guys like Intel or a lot of other Fusion IO, well, it's obviously if you can bypass the emulation, you're going to get something. But what I want to tell, emulation is also improving, because if you look at the first generation solid state drives, if you put like a normal database, like before Intel's, right? Intel's are quite good already. They were crap, right? Because of this rate level, you would see like, okay, well, it writes and then this, the performance drops to a cliff as soon as it starts to do this on-demand erase blocks, clean up for you and stuff, like, not in the background. And but that is getting better. On the same time, I think right, there's another Flash interface to be in development. Now another interesting thing, right? Two different types of solutions which are available right now is you can either get the drive, which is serial ATA, or you can get something which hooks to PCI Express internally or externally. Like Fusion IO is pretty well known. I think there's a bunch of other people I've seen doing something like that, just not so well known. While in memory also they have like appliance which hooks to PCI Express and just a lot of external flash. And
Violin doesn't actually reveal their flash though. Violin memory is, they show real, you're reading and writing to the RAM, and then Violin's got hardware and embedded stuff that's backing the DRAM up into flash. So
I thought they just did a complete flash a while ago now.
It's the only I've seen seen two products. One that's DRAM only, and one's DRAM running into flash.
Okay.
So if they have a flash only one, that one's new to me.
Okay. Well.
Someone's doing that.
What's that?
I was wondering if someone was doing that on the OS level, or the systems level, because that's been there's a couple of companies marketing for on the embedded level, basically flashback to DRAM modules. So, and they literally work with, they have some energy storage. So
the capacitors usually.
Yeah, the supercapacitor. And so basically when the power is cut, there's just enough energy left to write the contents of the DRAM to the little flash chip that's part of the device.
Yeah, that's right. And I think in a lot of cases that's also used like on the smaller scale, in a sense when you doing the writes. All those devices, when you do small writes in particular, they don't write them one by one. They try to accumulate it in the DRAM cache, and then write it as a whole block. But the problem here in this case, obviously, you can lose the data. And one approach is to ensure you have enough power so you can in the capacitor, right? So you can put that right ahead lowercase memory.
Yeah.
And I think that's like from my standpoint, I don't think DRAM code with the flash is that is a good, very good bet, because DRAM is DRAM, right? I would rather use my DRAM as a buffer pool or in NTP, where it has a bit different structure and so on and so forth, and then just write it to a disk, and it has to go to a disk, right? Double buffer just is all the place. But so basically, there's another choice either if it's PCI based or disk based, and I'm like, for me that's looks like a bit interesting, because I feel like the interfaces right now are not very mature yet, because pretending flash is serial ATA, that means going through so much hassle, protocol emulation. Flash is completely different stuff. At the same time, PCI Express approach is not very convenient for a lot of people, because it's not quite swappable, for example, right? You have to open the disk and stuff like that, and maybe we'll get into something, in the middle, like you'll get, I don't know, let's say, a bunch of hot swap of PCI Express slots or something like that, if you just plug onto direct or something like that.
That's what they do in the embedded world. That's actually PCI Express came from compact PCI from the embedded world, which was designed basically to have, like, say, a 3U chassis with hot swap PCI cards in. So I'm really surprised nobody's been bringing the rest of that world over into this kind of thing, because it would be relatively trivial to go to someone like Contron or something and say, give me a 3U CPCI slot, and then go to some, or chassis, and then go to someone and say, make me a whole bunch of compact or PCI Express.
Yeah. Well,
hot swap cards.
So there's that, but I know that the I got to see some of the the SuperCat backed flash units that Sun was working on before all that died. And their thesis was, it's easy to manufacture the JBOD equivalent of these things, but the two things that start getting very complicated very fast are power and thermal management on something that dense, and then your switching fabric, getting access to that much memory out to the PCI Express connectors gets interesting. That's what all of Violin's patents are on their switching fabric. All of Sun's patents are on their thermal and power handling for that much density. Yeah, because DRAM is DRAM, and we really want to have that much DRAM in our general purpose CPU servers to run our database on. But no one actually makes a motherboard that can handle the thermal and power and density of DRAM covering every square centimeter of space.
DRAM's ugly.
It chews a lot of power. It really surprised. It consumes a surprising amount of power.
Yeah, well, looking into some of the efficient server research, it was basically coming down to you can build something, you can build a system with a CPU that's matched nicely to the DRAM speed, but by using a slower CPU, basically. But yeah, your DRAM memory or power consumption dwarfs the CPU. It basically ends up being the 800-pound gorilla on the motherboard there. But yeah, what you gonna do? Sorry to distract.
No, it's actually quite an important part of these things.
So I mean, it's my expectation that we'll see some other interfaces which are kind of well designed for Flash, right? And you mentioned there's some protocol to access in the Flash, but it's also very.
That's what Gear 6 uses. We use the now newly standardized Direct Flash CFI Common Flash Memory Interface.
And it goes to what? Are you using the PCI Express or are you using the drives?
I've not actually seen inside my own boxes, so I don't know what the interface is.
Okay.
But the point is that we don't pretend the Flash is a hard disk. We understand the Flash is the Flash. We do reads and writes on the Flash's natural block size. And
Okay. Sure. So, but the fun stuff right here is there are very file systems, operation systems. They have so much stuff optimizations for the drives. You say, okay, you want to read and write serially. Random reads, random writes are bad. And all reads and all writes are random as well. Right? Because you have written certain block, and then the next block, if you have overwritten it separately, right, at a certain point in time, is going to be stored in a completely different case. And you absolutely have no idea what happens over time with this access, right? And also, internally, most of the internally the Flash itself is relatively slow. So what they typically use, they use internal something like RAID, and they strip across a bunch of blocks, and then use it concurrently. I think Intel Drive internally something like, is it 8 or 15 something of the sort channels, separate flash controllers, and when you read and write blocks, it's stripped across from them if it's a significant size, right? And they can access all of them in parallel to provide you and if you look at that stuff, that means that serial access they are not, they can actually overload those certain of those controllers. We've seen in some benchmarks was serial reads can actually be slower than random reads. The difference wasn't very large, right? Yeah, that's very counterintuitive, right?
Okay.
So for so if you look at that stuff, I think the file system with ZFS, that is a file system which was kind of very ugly for really normal hard drives. Why? Because it's copy on write. That means you just over time you get more and more fragmentation.
Mm-hmm.
This is bad, right? But for a lot of workloads. But with Flash, it works beautifully, right? Because well, it kind of gives you a lot of random reads, but Flash is good in random reads. And you go, and because of that, you can get this all copy and write, so it's like pretty much a free snapshots and like transactional writes and all kind of this stuff which file system doesn't provide. Great, Z write again. That's all stuff which are very much based on staging fragmentation for simplicity.
But you have to use Solaris.
Well,
Or
Solaris
CSD.
ButterFS has the same. ButterFS is also copy on write.
which one?
ButterFS.
Yeah, but I think it's better. It's not quite.
It's not ready.
I wouldn't say ZFS either.
What's it?
But
Yeah.
Well, I mean, I've seen them using it in ZFS in production, but
CFS is 12 years old? CFS is pretty old. Yeah.
Now, ButterFS is actually interesting for this kinds of applications, and I was thinking about that for direct database storage because basically it uses a fairly new data structure, which is a long structured tree, a long structured B tree. So, which ZFS doesn't use. And ButterFS was just kind of meant as an implementation of this new thing. And so when you have a B tree that is basically designed to be log structured like that very efficiently, that's got to work very well for storing indices and such like that. It's a bit different technology.
yeah, well, I think that's cool. That's kind of. I feel kind of a bit sad that Linux still doesn't have any good Flash design file system. I think so far what we've been getting the best results with is XFS, simply because it has less contention. Hotspots and ext3.
NilFS2 is supposed to be good for that.
Which one?
NilFS2. But again, this is all pretty new experience.
Well, yeah. I mean, we tried in NilFS, and then something like you let's say create, file, let's say half of your partition size. You go to write random writes to that and write and say, oops, out of free space. What the hell? Well, I mean, it turns out you actually have to do some maintenance on it to clean up and do stuff, right? Or, you look at that a while ago, and it just wasn't so. And the file system, the bad thing in file systems, and for the sake of storage engine, is because this stuff stores the data, you then better trust. I mean, you can try probably new MySQL version, well, if it crashes, right? You can roll back to a different one, but if you have a few terabytes worth of data and it just like now crashed, then you don't want it, right? You're supposed to have a backup and all this kind of stuff.
That's why you have a slave.
What's it?
That's why you have a slave.
Yeah.
I'm just joking.
Now, I'm curious. So now we've kind of talked a little about Flash technologies and techniques. I'm curious what, in your experience, works well as far as actually optimizing for when you have both Flash, both SSD and spindles available for your storage. I mean,
that is very interesting thing, right? I think a lot of people are now talking various ways to do that, and here is always aspect of a cache hierarchy across the radio saying, oh, now if you look at the really large scale stuff, we have DRAM, we have flash, and we have spindles, right? Like ZFS, and there's like one of success people had it like Sun appliances for storage just because of the ability to deal with this hybrid storage. The ZFS again, one of the approaches is what it can understand its hybrid storage, and I know some people they didn't buy Sun storage, but they would simply run OpenSolaris with a bunch of solid state drives and a bunch of hard drives which are configured appropriately with ZFS, and then get performance of hybrid storage. You can see, I think Facebook is doing some work on hybrid storage. Now you can see the guys who spoke about the waffle grid and stuff like that, and the one idea there is also to add the cache, add the flash to InnoDB, right? So and kind of make it also both automatically and manually manageable. Right? Cache those tables in flash, right? Not the open stuff like that.
Yeah, can I ask a leading question? What needs to be changed in the database to use Flash in multi-level caches? What does MySQL change? Because Facebook, I saw they were trying to split up InnoDB file per table even so that they could do data and indexes as separate files and put the indexes.
Well, that is one of the, I think there's different aspects here, right? One of them is say, okay, we can simply split, let's say, files and indexes as separate tables, and now we can put different index and different tables on different partitions. That's very cool, that's poor maths solution. The real interesting plans comes from if you have like this monster table, typically there are going to be some hotspots. Not all of the pages in that table are going to be accessed. Right? There's some old stuff, or maybe some you consider, let's say, like social network websites. Some users have their stuff uploaded and nobody goes to them, and they don't put their own stuff. It just sits there pretty much dead. And the interesting thing here is finding some sort of automation, right? So the system itself knows which data to keep in the cache and which not. And that is, I think, is a very interesting challenge.
Would make for an interesting bit of storage engine design, certainly.
Yeah, there is a bunch of startups right now also starting I think like there is anything DB which supposed to write stuff just completely flash optimized. There's some other guys who are doing that. PPXT is actually pretty good because it's sounds like more log structure thing, which obviously gives you more random reads, but it doesn't hurt anymore.
Yeah, I guess if you use a different implementation of indices, using again something like say a log structure B-tree. But I think initially, if you can just, I guess my thought was if you can, for at least for some types of tables, if you can basically move your indices over to Flash. It sounds like the approach you favor is basically letting something like ZFS figure out the details.
Well, yeah, because I would say, I mean, you still have to read the data in many cases, right? And if you're reading the data as a random reads, well, it's going to be a big problem. Now, there are a lot of interesting differences here, right? For example, with InnoDB, it has 16K page wide, right? Well, because we want to get a lot of data without a single IO, with Flash, it doesn't make sense.
Yeah.
Right, Flash, you can actually do reads and writes for smaller blocks, and that helps you both in terms of speed, and it's also increases the length of your kind of the time you can get from your drives, right? Because the less you write, the less time you can get.
Didn't you just post those benchmarks a few days ago?
What's it?
Didn't you just post some benchmarks on that a while ago?
No, on this website?
Yeah, on SSG. I mean, someone did. I can't remember who it was.
Yeah, well, I know what we did eventually. We also did some, some work for like a customer in this area, and they sometimes prefer not to
Sure.
publish his data, but there is a difference. Another thing is what a lot of things can get exposed which are not there, right? For example, InnoDB does a lot of magic in trying to merge the tape with pages and blah 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 to get sequential writes. So it trades CPU cycles pretty much to get a bit over from I/O. When your disk storage is slow, you can trade a lot of CPU cycles to minimize the I/O just a bit, right? Now Flash, first of all, those optimization doesn't make sense, but even more because you have so much I/O capacity now, you can be hurting yourself spending too much CPU trying to optimize I/O, right? Besides that, there's a lot of stuff, right? Like how it manages LRU, which again can become contention because certain mutexes and you say, hey, I get this mutex only when I do I/O, and because if with disk I can do maybe few, let's say 1,000 IOs per second if that is a good RAID volume, right? Well, this mutex wouldn't be hot because now if you happen to have a solid state drive, you can, and again, array of solid state drives, you can get like to 100,000 of IOs a second, right, or even more. And in this case, you get this mutex becoming very hot, and exploit the bottleneck which wasn't in there before. Checksums, again, the InnoDB checksum is kind of very slow. It wasn't the issue with slow hard drives, it became more an issue with solid state. And I'm sure you guys at Facebook will fix all of this and publish the patches, so I'm bored.
Do you just turn off the InnoDB checksum because the Flash is doing a checksum too?
Well, I mean, seriously, the hard drive also does checksums.
Yeah.
Right?
Yeah.
I mean, why do you need a checksum? Well, the checksums are there because they protect you to all levels. Like
Controllers
there could be controllers bugs, there can be kernel bugs, file system bugs, right? Whatever. Even like its own InnoDB bugs when it's gonna write some garbage to the wrong place.
Yeah.
Checksums protect you pretty much from all of them, right? So people tell me, like for example, the ZFS has its own checksum,
Yeah.
right? Sure it does, right? But that means you still are not protected from ZFS bugs and from InnoDB own bugs, right? If you disable checksums. I would much rather see checksums done faster because they can be done faster than trying to disable them. And I think that if you look at that stuff, right, over my experience, like even as my sum kind of usage significantly went down, I still see a lot more, let's say, random corruption issues with my sum than with InnoDB. And why? Well, in my opinion, because all the InnoDB corruption issues we were worked out already, because he is freaking paranoid.
Yeah.
He has checksum, he has assertions, he has a lot of those checks, right? And so a lot of those kind of inconsistencies were detected, found and back and fixed. And with my side, well, right? I mean, a lot of things just let them roll. Maybe you can just get some, data, unexpected data from a table which you don't notice. I mean, most of the apps store crap in the database, right? I mean, if you get some comment and you would have some one character which is different, who cares, right? I mean, right? Yeah.
So you talked a lot about what's coming up and all that kind of stuff. Aside, I think you did touch on the block size, but aside from that, what are some of the other practical, like right now?
Well, another interesting thing here is what we found storing the transactional redo log on the normal hard drives with BBU is faster. Why? Because you go to DRAM with which just pretty much goes there for PCI Express, and you can do like from single thread very many synchronous operations in seconds. With your hard drive with SSDs, it's better than hard drives. You can get maybe like 1,000 syncs a second. But with varied VVU cache, you can get maybe like 10, 15,000 a second. And log writes is serialized, right? So you're doing all of that stuff from a single thread. Another thing that you've seen is RAID controllers. Hardware RAIDs can suck at large extent because, again, this stuff is very much optimized to reorder requests and do this kind of optimization logic. And they have their CPU on this card, right? We just highly tuned for 150 IOPS per device, right, or something like that. And I mean, that is just how it's balanced. They obviously put their lowest performance processor out there, which is 100 the lowest. Now, if you replace those 150 IOPS a second device with 15,000 IOPS, which is like 2 or 5 faster, it just can't handle that. So most of the RAID cards which are on the market right now suck. And I think as we get some more SSD approved cards, it will be better. And you know what? And a lot of those RAID guys say we don't support SSDs.
Yeah.
I mean, it's not like they wouldn't work.
Yeah.
It's simply what we wouldn't deliver you performance. You Spectrum SSD, and these guys just don't want to be those who tell, hey, you know what?
I actually found pretty good, decent performance just by doing like software RAID.
Oh, absolutely.
Yeah.
Software RAID works, and that is what fine. You know, well, especially if you use something simple as RAID, you know, RAID 1, RAID 10, whatever. I mean, it's very simple. And we have a lot of CPU cores these days, right, which you can afford to waste because database and other aspects we typically have a lot of contention spots in them anyway. And so using some relatively cheap controllers which are dumb, I mean, we just don't try to do any smart things so we don't become bottlenecks. We found these are typically best utilization. And I think again that is there as Flash goes to mainstream, a lot of cool things is happening. We are to see soon, I think, controllers which are going to be, you know, Flash optimized and all that kind of stuff. Like, I know, for example, from Dell, they promised to start supporting SSDs like probably half a year ago, but it still didn't happen. I guess it's still working with all this stuff because a vendor like this has to, if they support SSD, they have to support hardware RAID SSD because that's their customers got used to, but then they have to ensure the RAID card they're using actually performs reasonably SSD.
Have you tried the Sun hybrids that they have now? The 4140 or 4150?
What's it? Well, we have customers to try it.
Okay.
Right. Like,
yeah. I was looking at that. $1,000 for 32 gigs. That's a little bit tough, though. Unless you really need it.
Okay.
Is it possible to do that on your own with OpenSolaris?
Yeah, well, OpenSolaris, ZFS, you can do it. I mean, some people could do it quite well. I mean, I'm not sure what exactly the same hardware what they're using, right? But you can.
Yeah, but get the Intel drives and OpenSolaris, and you can pretty much put it together.
And you can keep the hot data on the flash. And
Well, so ZFS will do a couple things for you. It'll make the flash a second level buffer pool kind of.
okay.
Yeah.
I guess I need to go. I have to plant the batch house. So,
Yeah. Thanks, Peter.
Okay, sure, guys.
Cheers, man.
Thanks.
Thanks.
Thank you, Peter.
You're welcome.